In this video, I'm thrilled to walk you through designing a quad package SMT IC. This device has electrical connections on all four sides and will feature gull-wing leads. I'll also show you how to design a no-lead QFN device, which offers a flatter, leadless design for better heat dissipation and a smaller footprint. Plus, I'll demonstrate how to add a central pad with optional thermal vias. So, let's get started. First, we'll need to create a quad parametric part. To do this, simply click on the Parametric Part menu button in the Home ribbon menu, and a dialog box will pop up, letting you choose from a wide range of devices. To create the quad device, click on the image for the device. On the right, you'll see a vertical collection of viewports that show from top to bottom. First, the schematic symbol, second, the footprint or land pattern, and finally, at the bottom, a 3D image of the automatically created 3D model for the device. Yes, DEX automatically creates 3D models for you without the need to import them from the internet, or even harder, to manually create them yourself using a 3D modeler program. Now, double-click on the quad package, the dialog closes, and the main application will open and display the footprint for the quad package, together with the schematic in a tab on the left and the 3D visual of the device in a tab on the right. In the Panels menu, click on the PCB and 3D button to display a viewport on the left showing the footprint and the 3D model on the right. If you do not see the Part Builder panel on the left of the viewport showing the footprint, click on the Part Builder button in the Panels ribbon menu. Now on the left, you'll find the Parameters section, where you can edit multiple parameters that define this parametric quad package. Starting at the top, you can change the number of rows and the number of columns. Below that, you can set the pitch, which is the distance between the individual pads. As you scroll down the left-hand side, you'll spot two group boxes showing the settings for the outer, inner, and center distances between the pad's columns and rows. Continuing down, you'll first encounter the X-gap control, which adjusts the space between the vertical columns of pads and the horizontal columns. Similarly, the Y-gap control manages the distance between the horizontal columns and the vertical columns. Below these controls, you'll find a control that lets you set the offset for the first pad name and decide whether the pads are named clockwise or anti-clockwise. There's also a checkbox that lets you add fiducials, though you might not need them often. Fiducials are alignment marks used by pick-and-place machines to precisely place parts before soldering. As you keep going, you'll find a set of radio buttons to choose the type of lead you want. The options are gull-wing, leadless, J-lead, and plain straight. Next, you'll find the controls at the bottom, which let you add a central pad. A central pad is often used to help cool the device. To add a central pad, simply click on the Add Central Pad checkbox. A new pad will be automatically added between the rows and columns of pads. You can also set how much space or clearance there is between the center pad and the pads around it. If you want to add thermal vias, you can do that too. Thermal vias are used to transfer heat from the base of the part to the other side of the PCB. If you decide to add thermal vias, the pad will change from a surface mount pad to a two-sided pad because you need vias to connect the top and bottom. If you decide to remove the vias, the pad will automatically revert back to a SMT pad. You can route PCB tracks to both the top and the bottom sides of the central TPH pad. I hope this video is helpful, and I really recommend giving it a try yourself. Experimenting with creating your own quad package can be a fun and rewarding experience. Thanks for watching.